Alright, we're doing FBDs page 2. We're drawing free body diagrams for each of these objects. I'm not drawing any system schemas, I'm just discussing what objects it's interacting with, but if you need to draw system schemas, go ahead and do that for sure. If you ever have any doubt about what forces are acting, system schema is the way to go. So we're drawing a force diagram for the box. So it's interacting with the earth and the rope. So its weight is mg, and the tension is up, and the forces are balanced here because it's moving with CVPM. It's moving at constant speed. Again, the direction of motion is not on the force diagram. That's just not related to that. Okay, this box is motionless. It's interacting with the earth and the table, and then this block behind it. So there's the weight, and always a good idea to draw in that diagram, or that incline with a dotted line. So I know there's a normal force from that bottom incline. And then there's a normal force from this one that's perpendicular to it, so it's pushing it that way. So I'll call them normal 1 and normal 2. Alright, our object is pulled by a force parallel to the surface. We don't say anything about friction, we'll assume there isn't any. So it's interacting with the earth, as usual. It's also interacting with the table and with whatever this pulling force is, whatever object is doing that. So there's a normal force and there's a pull. This is a kind of, if it's a pull rather than a push, it's a tension. The diagram named it F though, so I'll go ahead and name it F. Alright, in 12, pulled by a force at an angle to the surface. Again, it doesn't say anything about friction, so I'll leave it out. This object is interacting with the earth, with the table, and with the rope or whatever is pulling it. So it has a weight. There is a normal force, which is not quite big enough to balance the weight, because if you'll notice, the F is kind of pulling up too, right? So those combined sort of ups of the N and the F have to equal the down of the mg if it's not going to, if it's going to be CVPM in that dimension. It's not going to fly up off the table. Alright, object is falling, no air resistance. So the object is interacting with the earth, and that's it. Not touching anything else, nothing else acting on it, just its weight is the force on it. Okay, object is falling at terminal velocity. That means that if it's falling with constant velocity, that definitely means air resistance is important, so we can't ignore it. It's still interacting with the earth, but now it's also interacting with the air, and if it's falling at constant velocity, that air force must balance the weight. Ball rising in a parabolic trajectory. Okay, if you're not told that air resistance is important, then it's not in general. So let's look at what it's interacting with. It's interacting with the earth, and that's it. This one at the top of its trajectory, it's motionless right now. It's stopped, but what's it interacting with? Just the earth. Okay. So all three of these, 13, 15, 16, all the same force diagram because they're all just interacting with the earth. So they all have the same acceleration. Hey, wait, that sounds familiar, right? We knew that back from CAPM with freefall, and this is kind of why.